Hello, today we will be looking at finding the distance between 2 points on a coordinate plane. If you have a point, P1, located here, and you have a point P2, located here, and you want to know the distance, which is what we have here indicated in yellow, to find the distance, you can think of the distance between the 2 points as the length of the hypotenuse of a right triangle. So if we draw out a right triangle, then essentially you can use the Pythagorean Theorem, which we will talk about in a different video. But essentially what the Pythagorean Theorem states, a squared plus b squared equals c squared. And that is essentially stating a squared plus b squared equals c squared. So we're just using the Pythagorean Theorem, and by utilizing the distance between the point here, which we'll call f, so using the distance between P1 and F and P2 and F, that's how we're able to get C. We're not going to go through the proof on how to calculate the distance, but utilizing the Pythagorean Theorem, from that, the distance formula, which is what we have located here. So we're saying the distance between P1 and P2 is equal to the square root of the quantity x squared minus x1 squared plus y2 minus y1 squared. Now that we understand the distance formula, let's look at a couple problems where we can apply these to different examples. We have the point P1, 7, negative 3, and we have the point P2, 3, negative 3. If we wanted to see this on a graph, we can actually plot it. And so that would look like point 1 here, and then the next one is 3, and we're also negative 3. So if this is point 1 and this is point 2, we are trying to find the distance between point 1 and point 2. We can use our distance formula that we just learned, and so that's going to be the distance between P1 and P2, and that's going to equal the square root of x2 minus x1, that quantity squared, plus y2 minus y1, and that quantity squared. Now, just so you know, it doesn't matter which point is P1 or which point is P2 as far as your x2 and x1. If you keep the x coordinate and the y coordinates the same in the equation, it doesn't matter which point comes first or which point comes second. But because these are labeled P1 and P2 already, let's just use those so we don't get confused. So looking at the equation, we're going to plug in x2. So we're going to use x2 here, and we're going to subtract it from x1, and then we're going to use y2 and subtract it from y1. When we do that, we get the square root of 3 minus 7 squared plus negative 3 minus, and it's a positive, plus 3, and that is squared as well. Okay, if we simplify this, then we're going to get the square root of 3 minus 7 is negative 4, that quantity squared, plus negative 3 plus 3 is 0, and 0 squared is 0. Now we just simplify this. We have the square root of negative 4 squared, which is equal to 16, and this is equal to 4. And this is our answer. So that's saying that there's a distance of 4 between point P1 and P2. And because we know that this is a horizontal line, because both of the y coordinates are similar, then we know that this is 4 units, and so we actually can see from 3 to 7 is a distance of 4. And so that's how you would use and apply this distance formula. Now that we know how to apply the distance formula, let's look at a more advanced example so we can see how else to utilize this formula. Okay, looking at our next problem, we have the points A at 8, 5, B with the point of 1, -2, and C located at -3, 2. So the question asks, show that A, B, and C is a right triangle and find its area. If we connect the points on this graph, we are trying to show that, again, A, B, and C is a right triangle. And so, if we think about the Pythagorean theorem, we know that for a right triangle, a squared plus b squared is equal to c squared. So in this case, AB, the distance of AB squared plus the distance of BC squared is equal to the distance of AC squared. And so what we need to do then is find the distance between all of these points and then see if the computation, when plugging them into our Pythagorean theorem of a squared plus b squared equals c squared, holds true. Using the distance formula, recall that the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. If we write out our points, our first point is A at 8, 5. We have B at 1, -2, and we have C at -3, 2. So what we'll need to do, again, looking at the Pythagorean theorem and understanding what a right triangle is, we need to find there's the distance between A and B. We need to find the distance between B and C. And then we also need to find the distance between A and C. Okay, so if we look at the distance between A and B, then we're going to use these two terms. Using these two terms, it doesn't matter which one's x2 or y2. So for the distance of A and B, we have the square root of, we have x2, which in this case we're going to say is B, minus 8, which is x1 squared, plus y2, which is -2, minus 5, which is y1, and we have that squared. If we look at the equation for our second one between B and C, we are going to get the square root, using C as x2, we're going to get -3 minus 1 squared plus 2 minus a -2, which means that's a +2 squared. And then lastly, to get AC, which is this one here, we need to do the distance between A and C. So that's here. We're going to use C as the value of x2, y2. So we take -3 minus 8 squared plus 2 minus 5 squared. All right, now we need to simplify. So we have the distance of A and B, and that's going to, after simplifying, we get 1 minus 8, which is 7. The square 1 minus 8, which is -7. -7 squared is 49. And then we have 2 minus 5, which is -7. -7, the square root of that, again, is 49. So we have the square root of 98. All right, looking at our distance between B and C, we have -3 minus 1, which is -4, and we square that. -4 squared is 16, plus 2 plus 2, which is 4. 4 squared, 16. So this is equal to the square root of 32. And then lastly, we take the distance between A and C, and this is equal to the square root of -3 minus 8 squared. -3 minus 8 is -11. -11 squared is 121. And then we take 2 minus 5 squared, so that's -3 squared, which is 9. And this is equal to the square root of 130. Now that we have the distances between AB, BC, and AC, all we need to do is plug these values into our Pythagorean theorem located here to confirm that this is a right triangle. So we need to ensure that AB squared plus BC squared equals AC squared. So let's check to see if that works out. If we have AB squared, we have the square root of 98 squared plus the square root of 32 squared, which is supposed to be equal to the square root of 130 squared. All of these are squared, so the square roots can go away. So we just have 98 plus 32 equals 130. And that says that 130 is equal to 130. And this checks out, and that's how we know that this is a right triangle. Now what we need to do is find the area. Moving this over, we have the triangle, which is what we just found out. Let's move this back over real quick. So we have A, we have B, and we have C. BC, what we know, is the square root of 32. We have AB, which is the square root of 98. And we have CA, which is the square root of 130. That's the distance. Now that we have our values, we ask ourselves, what is the area of a triangle? Well, we know the area of a triangle is equal to 1/2 times the base times the height. We know the base, in this case the base is BA, and we know the height, in this case it's CB. All we need to do is plug in those numbers to find area. We have 1/2 multiplied by the base, which is square root of 98, times the height, which is the square root of 32. Rewriting this, we have the square root of 98 times it by the square root of 32, all over 2. 98 times 32, using my calculator, this gives me the square root of 3,136, and that's going to be divided by 2. The square root of 3,136, again using my calculator, is going to give me 56 divided by 2, and 56 divided by 2 is 28, and this is the area and our final answer. This question is a little bit more involved. At first, we needed to find the distances between the points that they gave us. From there, we used our understanding of triangles to see if the distances that we got make a right triangle. After we checked that this was in fact a right triangle, we were able to use the geometry of triangles to understand what the area of this triangle was. Again, a little bit more complex. However, utilizing all the information that we know, we were still able to come up with a solution. Please let me know if you have any questions by leaving them in the comments below. If you learned something, please like and subscribe, and we'll see you next time.